In this video, we're going to discuss scalar quantities and vector quantities. We will compare them to know the difference between them. If two kids are racing alongside, can you tell who's faster? You can measure their speed by either measuring the distance crossed at the same time or see who crosses the same distance in a shorter time. Measuring distance or speed could be helpful. But what would we do if they are running in different directions? Speed and distance would then be useless because they are scalar quantities. They only measure the magnitude. There's no account for the direction. Temperature and pressure are a good example of scalar quantities. For example, I can never say that my blood pressure is 12/8 to the east, or that the temperature is 20 degrees to the left. Vector quantities, on the other hand, measure both magnitude and direction. All forces, including weight, are vector quantities. They always point towards a certain direction. If we take the weight, for example, it always has the same direction towards the ground or the center of the earth. Direction can define vector quantities. Slight changes in the direction make a big difference. Take this ball, for example. If I apply a horizontal force to it, it will end up in the net. While small change in the direction can make it miss the net and divert away. As we have seen before, some quantities, like pressure and temperature, can only exist as scalar. In contrast, some vector quantities are obtained by adding direction to a scalar quantity. The reason we do this is because some instruments, like speedometer, can only measure the magnitude. Displacement, for example, is obtained by adding direction to a distance. In the same way, velocity is obtained by adding direction to speed. What's important to notice is that the distance is measured in meters, kilometers, or miles, while for displacement, you have to specify the direction. For example, we say 50 meters to the east or 30 kilometers on a 30 degrees bearing. Same goes for speed and velocity. Speed is measured in meters per second, kilometers per hour, or miles per hour. Velocity is measured in the same way. We should either specify the direction, east, west, north, or south, or we should specify the bearing. Now let's say, for example, I am at this point in town, and I want to head to the stadium, which is about 50 meters to the southwest. If I would have gone straight to the stadium, the distance would be 50 meters, and my displacement would be 50 to the southwest. Now let's say that I did not take that path. Instead, I went left, following an ice cream truck to get a cup of ice cream. After moving 30 meters to the left, I continued my way to the stadium, which is 40 meters south. If I calculated my distance using a speedometer, it would be 70 meters, since the speedometers usually add the 30 meters to the 40 meters. But my displacement, on the other hand, would remain the same, 50 meters to southwest, because displacement only calculates the difference between the starting point and the end point, even if I went all the way around the town. In that case, the displacement crossed might be 100 meters, or 1,000 meters, or maybe 5 kilometers. And my displacement would remain the same as long as I start from the same point and end up at the same point as well.